Welcome to Chapter A of our new course on normal gravity, which I will nickname Geodesy. The first Chapter A is the syllabus. And you have the syllabus, you can download it from my website, drphys.com. The first part of the syllabus is Section A1, the course description. Now, the course is for students that have 1 year of calculus-based physics and 3 semesters of calculus. That would be a year and a half. So if you were in college, this would be finishing your sophomore year in a major, say, physics or atmospheric science, for example, engineering. I have structured the course from A to Z. Topics will include, first, a review of algebra, trigonometry, and some physics and calculus. But the review is not going to be comprehensive in those areas. It's just going to review the algebra and trig and calculus we need for the course that we'll be using in this course. But it will be a pretty good review. Then we'll look at, from Calculus 2, I think it is, infinite series. It's important that we understand when a series converges and it doesn't. Then we'll look at gravitation, and then we'll look at properties of the ellipse, the circle and the ellipse. And we'll lead into 2 dimensions where we describe with coordinates 2-dimensional space. So you're like your X and Y and Cartesian coordinates or your polar coordinates leading to elliptic coordinates. Eventually we want to deal with 3 dimensions. So we'll go to curvilinear coordinates and then look at cylindrical coordinates, spherical coordinates, and ellipsoidal coordinates. We are going to model the Earth as an oval, an ellipsoid. You take, for example, an ellipse, and if you have an ellipse and you spin it around like the vertical axis, you'll then sweep out a nice 3-dimensional solid that we're going to be looking at. We call that the oblate spheroid. Right, oblate spheroid, when it's like this, if it were this way, it would be a prolate spheroid. And then we'll be needing the Laplacian. So we'll be looking at the Laplacian, and then we'll look at, eventually, toward the end of the course, solving the Laplacian in ellipsoidal coordinates to find normal gravity.